Welcome to Study Loop.
So let's see, we have a couple of statements here that we'd like to negate without actually using the negation symbol not. To do that, I'm going to first make this a little bit skinnier. And then we'll note here that the negation of for all x something is true of x is precisely there exists some x such that phi of x is not a lie. So if it is not true that every x has some property, that is the same thing as saying that there is some x that does not have the property. And conversely, if there does not exist an x, some property, that is the same thing as saying that all x do not have that property. So we'll use those two things and the negations of these formulas to do what we want here. So we have for all x, x is greater than 1. For all x is greater than 1. To negate that, we'll do there exists some x where x is not greater than 1. And in particular, x is not greater than 1 means that x is less than or equal to 1. And there we go. For part B, our statement is for all x, I keep doing my parentheses too soon, for all x is less than or equal to 2. When we negate that, it means there exists an x such that x is not less than or equal to 2, and if x is not less than or equal to 2, x must be greater than 2. See here, there exists an x that is greater than or equal to 4. To negate that, we say for all x is not greater than or equal to 4. What does it mean for x not to be greater than or equal to 4? Well, it means that x has to be less than 4. D here, there exists an x such that x is less than 0. We negate that. It means for all x is not less than 0. What is not less than 0? Why, things that are greater than or equal to 0, of course. Part E, we're almost done. We're saying for all x is less than negative 1 or greater than 2. To negate that, this is a little bit more interesting. There needs to exist an x where this is not true. X is not either less than 1 or greater than negative 2. Here we'll use De Morgan's law. So x is not less than 1 and x is not greater than 2. What's that? Well, so there exists an x. I forgot to write x there. Where x is not less than 1, which means less than negative 1. So it must be greater than or equal to negative 1. And x is not greater than 2. So x needs to be less than or equal to 2. Note that, of course, this is greater. Yeah, no, this is fine. Now for f, I've already scrolled past what we needed. Let's see. We're saying that their statement is that there exists an x that is less than 4 and greater than 7. Right? To negate that, we swap the quantifier. For all x, we have that there is not x is less than 4 and greater than 7. Right? Which by De Morgan tells us that x, for all x is not less than 4 and x is not greater than 7. To negate this, if x is not less than 4, x is greater than or equal to 4, and x is not less than 7, which means it's less than or equal to 7. And so there we go. There we've negated all of these statements just by using this quantifier switching business, and in the last two cases, De Morgan's law, to not have any not symbols in it.